Now in this first example problem, I have been given 10 as my focal length and 30 centimeters as where my object is. The first ray is going to go from the top of the object to the mirror and then through the focal point. The second ray is going to go from the object through the focal point and then parallel back. And the third ray is going to go from the object through the center and down to the mirror. And where all three of these lines connect, right here, will be where your image will show up from the object. So now I'm going to be using the mirror equation, or 1 over P plus 1 over Q will equal 1 over F. Now I can rearrange this because I need to isolate my image distance to calculate it. So I can rearrange this by writing 1 over Q equals 1 over F minus 1 over P. Now to solve, I just need to fill in my variables. So I then write 1 over Q equals 1 over 10 centimeters minus 1 over 30 centimeters, which then I'll have to do the inverse of what I got here, which will end up leading me to 0.067 over 1 centimeter, and then I find the inverse of this function, which will lead me to Q is equal to 15 centimeters. Now I'm going to find the magnitude, which is represented by M equals negative Q over P. And my Q value, which I just found, would be negative 15 over 30 centimeters, which is my object's length, which is going to give me negative half centimeters. And because of these two equations that I have just done, I have found out that my image is real, it is smaller than the original, and it is now inverted or backwards, represented right here. So now I'm going to be drawing a concave mirror, and here's my given find, and I need to find the position of the object, the magnification of the image, and the height of my object. And right here, I have already drawn out for you the array diagram indicating where my image and everything should be located. Now I'll do the calculations. So now I'm trying to find the position, and so I've done my calculations, and I have 1 over negative 8 minus 1 over negative 4.44, and then I find the inverse of that, which is represented here, and then I come up with 10 centimeters as my position where it should be. Now moving on to the magnification, the equation is negative Q over P. So, and because this is already negative, it just changes and becomes positive. So 4.44 divided by 10 centimeters equals 0.444 for the magnification. And now I move on to find the height of my object, which would be just negative P divided by Q times the height, which was given for us at the beginning of the equation. So now I move on to negative 10 divided by negative 4.4 times 2.5 equals a height of 5.63 centimeters.